Okay, let's do an example. We are going to solve an equation. Before we do the example, let me explain what the directions mean. So when you are asked to solve an equation, what they're really asking you to do is to find all the solutions to that equation. And remember what a solution is. It is a number that makes the equation true when you plug it in for x. So it's all the values of x that make the equation true that we want to find when we're asked to solve an equation. All right, so let's take a look at an equation. We have 2x plus 8 equals 5x minus 4. Now to solve this equation, we could try to guess numbers to plug in for x to see if it comes out true or false. But the problem with that is there is an infinite number of choices that we could make for x, and we would technically have to check every single one to make sure we find all of the solutions. It does turn out for this type of equation that there is usually just one solution to the equation, but sometimes we might not know that ahead of time, and we really couldn't be sure that we found them all unless we checked everything that was possible, which again would be an infinite number of things to check. So guessing isn't really the best way to solve an equation. Also, it could end up taking a long time doing it that way. So what we could do instead is we can manipulate the equation into telling us what the solutions are. So we don't have to guess and tell it what we're guessing. It will tell us what the solutions are. And all we have to do is get the equation into the form of x equals some number. And the equation is just then telling us what the solution is. Right? In order to get the equation to tell us what the solution is, what we need to do is isolate x on one side of the equation. And you're probably already familiar with this technique. So what I'm doing here is I'm subtracting 5x from both sides of the equation. I'm subtracting it from the right-hand side to eliminate x from the right-hand side. Right? If I want to get to a point where I have x equals some number, I can't have x on both sides of the equation. It needs to be eliminated from one side of the equation, and I'm choosing to eliminate it from the right-hand side. So that's why I'm subtracting the 5x from the right-hand side. But in order to keep the equation equivalent to the original, we have to do the same thing to the left-hand side. This is known as balancing out the equation, and essentially comes down to whatever you're doing to the right-hand side, you have to do the same thing to the left-hand side. If we fail to do that, it alters the nature of the equation, and we won't get a solution to the original equation we started with. We'll get some solution to some other equation that we don't care about. So we are subtracting 5x from both sides of this equation to eliminate it from the right-hand side and to balance it out on the left-hand side. And all we're going to do here is combine like terms. So on the left-hand side, we're going to get 2x minus 5x. Those are like terms, which ultimately gives me the negative 3x. The plus 8 just gets copied down. On the right-hand side, the 5x's cancel each other out when we combine those together, so that just zeroes out. It doesn't exist anymore. And then the minus 4 gets copied down, and then we kind of read it as negative 4. So you'll find that minus 4, negative 4 kind of is interchangeable. Just kind of depends on the context of the situation. So it's going to now be regarded as a negative 4. And because we did the same thing to both sides, we know that these results are still equal to each other. That's what makes these equivalent equations. They're equivalent because they will retain the same solution set. Even though we've changed the way it looks, the solutions are still going to be the same. And we guarantee that by doing the same thing to both sides of the equation. All right, so to continue towards our goal of getting x equals some number, we want to isolate the x, meaning we want to get rid of the negative 3 and the plus 8. That stuff needs to be eliminated also so that we have x by itself. And the first thing we're going to get rid of is the plus 8 by subtracting 8 from both sides of the equation. So I'm going to subtract it from the left-hand side to get rid of the 8 from the left-hand side, but to balance out the equation so we're not changing our solution set, we have to subtract 8 from the right-hand side as well. Right. Combining like terms, the negative 3x gets copied down. The 8s are going to cancel out. The plus 8 and the minus 8 cancel each other out. On the right-hand side, we get negative 4 minus 8, which is negative 12. Be careful when you're doing that arithmetic. You don't want to make a mistake there. And again, because we did the same thing to both sides, we know that these results are still equal to each other and that this equation is equivalent to the previous two equations. It has the same solution set as the previous two. And now we need to get rid of that negative 3, which is being multiplied to the x, so the dot indicates that we're multiplying there, and to cancel out a multiplication, we divide by that number. So we're going to divide by -3 on both sides of the equation. And what we're going to end up getting is x equals 4. And again, we're manipulating the equation into telling us what the solution is. So the equation is now telling me that x must be equal to 4 in order for that equation to be true. And I know that this is the only possible solution, because if there's any other solutions, we would have found it through this process. So the solution to the equation is x equals 4. And we have now solved the equation.